We will continue the course for commercial mechanical inspector test. Now we are in the last module, this module number 14, cooling. Recommended study time 150 minutes. Module 14, required reference. It is International Mechanical Code, chapter 3, 9, and 11. Cooling. Illustration 14a, cooling unit. Also, we close out the commercial mechanical as we close out the commercial mechanical course, we end with cooling. The regulations that govern specific cooling appliances. We will also discuss the provision of hydronics that are specific to cooling, also with minimum requirements for design, construction, installation, and operation of refrigeration system. Study tip, chapter 11 in our International Mechanical Code has regulation pertaining to the life safety of building occupants with minimum requirements to achieve the proper design, construction, installation, and operation of refrigeration system. We will cover chapter 11 further down in this video. How refrigeration system work?
How refrigeration systems work. Refrigeration systems are a combination of interconnected components and piping assembled to form a closed circuit in which a refrigerant is circulated. The system's function is to extract heat from a location and to reject that heat to a different location.
Condensate disposal. International Mechanical Code 2021, Chapter 3, Section 305. Air in occupied building contains moisture or humidity. As the temperature goes up, the air can hold more moisture. Illustration 14b, condensation. As the temperature drops, as in cooling system, the air can hold less moisture. When cooled below the dew point of the air, the moisture comes out as condensate. Mechanical equipment that can condensate water out of air is said to be doing latent cooling. Condensate drain systems are required for any equipment doing latent coolant. Condensate drain systems have code requirements. Let's take a look. Study tip. Requirements for condensate drain system. Piping must maintain an 1 per 8 12 slope, 1% slope. Discharging to street or other nuisance causing area is not allowed. Piping must be at least 3 by 4 inch in diameter. Sized per table 305.1.2. This is based on how many tons of refrigeration are connected to the pipe. If multiple units are tied together, the sum of equipment capacities is used. A trap is required, or for ductless mini splits. An inline check valve must have clean outs in the pipe so blockages can be cleared without cutting the pipe. The total capacity range and the minimum condensate pipe diameter, for example, from 0 to 20 ton, the capacity of the unit, it will give 3 by 4 inches and so on. So this illustration 14c is minimum condensate pipe sizing. The minimum pipe diameter is based on total capacity. Auxiliary drain systems. Auxiliary drain systems are required where damage to building component could occur because of the primary system overflow. Auxiliary system options. 1. An auxiliary drain pan with a separate drain discharge to conspicuous location. 2. A separate overflow drain line connected to the primary drain pan at a higher location than the primary drain, discharging at the conspicuous location. Number 3, an auxiliary drain pan with a water level detection device that shut off the equipment before overflow. Number 4, a water level detection device that shut off equipment with detection installed in the primary drain, overflow drain, or equipment drain pan above the primary drain line and below the overflow rim. This condensate pump. Illustration 14D condensate pumps. Option 4 is required for condensate pumps in uninhabitable spaces such as attics, crawl spaces, and plenum. Cooling towers, evaporative condensers, and fluid coolers. International Mechanical Code 2021, Chapter 9, Section 908. Illustration 14E, evaporating cooling equipment, cooling towers, evaporative condensate, and fluid coolers. All use evaporation to cool down water or refrigerant. Water is sprayed over a media that air passes through with the assistance of a fan. The discharge of humid air that often contain droplets. The droplets can contain bacteria or other contaminants, so they should be located so the discharge can not enter the occupied space. Illustration 14F, plume discharge. The plume discharge must be at least 5 feet above and 20 feet away from any ventilation inlet to building. Illustration 14G, drift eliminator. Cooling towers and evaporative condensate required. This, the drift eliminators. Cooling tower and evaporative condensers require the drift eliminators that don't allow more than 0.005% of the circulated water flow rate to drift. Drains, overflow, and blowdown are to be indirectly connected to an approved disposal location. Mitigating disposal as water evaporators, the salt and mineral left over in the water become more concentrated, which allows them to become more electricity conductive. If allowed to build up, the salt and the mineral will begin dispersion on the media and will block the system.
System bleeding. Automatic system bleed is required. Implementing a system bleed can be based on conductivity, a fraction of metered makeup volume, metered bleed volume, runtime of the recirculating pump, or bleed time.
Evaporative cooling equipment is International Mechanical Code 2021, Section 928. This section of the code lists requirements for evaporative cooling equipment. You can check out the reference section as you read through the list below and read through this section in the code. Study tip, evaporative cooling equipment requirements. Number 1, installed on level platform. See section 304.10. Number 2, have flashed opening in exterior wall of or roof per than IPC, International Building Code. Have an approved water supply size for peak demand. Have air intake opening location in accordance with section 401.4. Refrigeration, International Mechanical Code 2021, Chapter 11. We now turn to Chapter 11, covering the regulation pertaining to the life safety of building occupants. Understanding the field, refrigeration systems are a combination of interconnected components and piping assembled to form a closed circuit in which a refrigerant circulates. The system's function is to extract heat from a location or a medium and to reject that heat to a different location or medium.
Reasonable safeguards. This chapter establishes reasonable safeguards for the occupants by defining and mandating practices that are consistent with the practices and experience of the industry. It provides for the protection of life and property from the potential fire and health hazards associated with refrigerant chemicals and the machinery that contains such chemicals.
Some refrigerants are toxic, some are flammable, and some are both. This chapter will also refer to in the International Mechanical Code Fire Code ASHRAE 15 and AAR standard 2 through 5 to address this hazard. General refrigerant requirements International Mechanical Code 2021 Section 1101. It is necessary to comb through the mechanics and thermodynamics of refrigeration cycle in our studies. It is, however, important to note that refrigeration cycle includes the repeated vaporization and condensation of fluid. Think about it. The fluid described above is, by definition, a refrigerant, and while water can be used as refrigerant in system where liquid water is cold and heated but never vaporized, water is not acting as a refrigerant because it is not part of the refrigerant cycle.
Maintenance on mechanical refrigeration. Mechanical refrigeration systems should be maintained in proper operating condition and free from the accumulation of oil, dirt, waste, excessive corrosion, other debris, and leaks.
Illustration 14H refrigerant types. If a refrigerant circuit has more than 220 pounds of group AI refrigerant or 30 pounds of any other group, the code official must be noticed before the refrigerant type can be changed. We will explain this group later in this module. This is a very important point. Let's read it again. If a refrigerant circuit has more than 220 pounds of a group AI refrigerant or 30 pounds of any other group, the code officials must be notified before the refrigerant type can be changed. Illustration 14I access ports. This is access ports. Okay, this is how we can open refrigerant circuit access port located in outdoor publicly accessible areas require locking type, tamper resistance cap, or shall be otherwise secured to prevent unauthorized access. System requirements International System Requirements International Mechanical Code 2021 Section 1102. The system classification allow refrigerants maximum quantity, enclosure requirements, location limitation, and field pressure test requirements are addressed in Chapter 11. Take a look at our graphic below summarizing these steps that are necessary to determine the refrigerant system. We will refer back to this step throughout the module as we get to each other. Study tip determining the refrigerant system. Number one, determine the refrigerant classification. International Mechanical Code 1103.1 determines the occupancy classification. International Mechanical Code 1103.2. Number three, determine the refrigerant system classification. International Mechanical Code 1103.3. Number four, determines the system enclosure requirements. International Mechanical Code 1104. Number five, determines the maximum allowable quantity of refrigerant. International Mechanical Code 1104 based on 1, 2, 3. Note that refrigerant equipment and appliances location are covered in International Mechanical Code Chapter 3, while the pressure testing of non-factory tested field erected equipment and appliances is covered in Section 1108. Refrigerants, International Mechanical Code 2021, Table 1103.1. The refrigerant must be what the equipment or appliances was designed to utilize or converted to utilize. Refrigerants not identified in Table 1103.1 must be approved before use. Fast facts, refrigerants of different designation in ASHRAE 34 cannot be mixed in a system except where permitted by the manufacturer to improve oil return at low temperature. We will go into table 1103.1
Refrigerant source.
in more
Refrigerants
detail
must
down
be
below.
new, recovered, or reclaimed, and of a purity specified by the equipment manufacturer. Where required, the installer must furnish a signed declaration that the refrigerant used meets the requirements.
Defining terms. Recovered refrigerants are refrigerants that are pulled out of equipment and stored in an external container without being tested or processed. Recovered refrigerant can only be used for equipment of the same owner. Reclaimed refrigerants have been tested to meet purity requirements of ARI 700 and cleaned. If necessary, reclaimed refrigerant can be used in any one equipment. Refrigeration System Classification, International Mechanical Code 2021, Section 1103.1. Over the next several sections, we are going to walk through the steps necessary to determine the refrigeration system classification. Follow along closely. References the relevant tables and sections as we take you through the process. Refrigerant classification. Step 1 determines the refrigerant classification. This is the first step to determine the refrigerant system. Refrigerants are classified per ASHRAE 34 as listed table 1103. This is the table 1103. This is the chemical refrigerants. This is the formula, chemical name of blend and everything. Illustration 14G going over table 1103. It feels like you need a degree in chemistry to understand this table. Only with one picture. We have written key points and some interesting extras to help you understand the table as we walk through using the subsequent illustrations. You still might feel like you need to study chemistry to fully understand it, and that wouldn't be completely inaccurate. Here is the table. Okay, illustration 14K is column 1. Column 1 is chemical refrigerant. The refrigerant numbering system was created by Topent in 1956 and since has been adopted by ASHRAE 34. The ASHRAE 34 Technical Committee is responsible for assigning numbers to new refrigerants. Generally, the number assigned to refrigerant contains information in each digit about its chemical composition. Study tip. We will walk you through this as well in case you are interested. If not, don't let this spook you. It is not going to appear on the test. The ones place of fastest digits to right, number of fluorine F atoms in the molecule, the tens place or second digit from right, number of hydrogen H in the molecule plus 1, in the hundreds place or third digit from Write number of carbon C in the module -1. Important note, this only hold true through 200, then the 100 place is assigned to other types of molecules. Study tip: molecule described from 000 series through 1000 series. 000 series methane-based compounds, 1 carbon. 100 series ethane-based compounds, 2 carbons. A lower case suffix started to get used in 100 and 200 series that indicate the different arrangement of the atom in the molecule. 200 series propane-based components, 3 carbons. 300 series cyclic organic components. This is where the numbering system starts to fall apart. 400 series zeotropic, a mixture that can be distilled, that it is the component have different boiling points. A capital letter suffix A, B, and C distinguishes different quantities of the same component. For example, R410A and R410B are both mixture of the same components but mixed in a different quantities. 500 series is azeotropic, a mixture that has a constant boiling point. All components boil at the same time, making distillation impossible. 600 series organic components. This classification is for all the organic that don't fit into 000 through 300 series. 700 series inorganic compounds. Example R718 is water. 1000 series understand organic components that organic compounds with double bond. The meaning of each digit is the same as the 000 through 300 series. Illustration 14L, column 2, formula. This is the formula. This is the chemical formula for the compound of zeotrope, if it's a mixture. Column number 3, this highlighted blue, illustrated 14M, column 3, chemical name of blends. This is chemical name of blends. This column shows the chemical name of each refrigerant, while the chemical name may look little confusing at first glance. You can see that the words do correlate to the chemical abbreviation found in column 2. Here, number 4, illustration 14 in column number 4, refrigerant classification, this one, this important one. This is a simple classification of the risk that the refrigerant poses. The letters A or B refer to toxicity. A is lower toxicity, no toxicity identified below 400 ppm, while B is higher toxicity. The number 1 and 2 or 3 refer to flammability. 1 is no flame progression, 2 is lower flammability, and 3 is high flammability. So this letter is for toxicity, is for refer to toxicity, and the number is refer to flammability. Illustration 14O, this is the column number 5, amount of refrigerant per occupied space. except for the occupational exposure limit OEL. Each of these columns is represented the same information in different units. The last one, illustration 14b, column 6, degree of hazards. The degree of hazards is a standard label that is required on shipping containers that represents the health, fire, and reactivity hazards of the substance. Occupancy and classification, International Mechanical Code 2021, Section 1103.2. Step 2 determines occupancy classification. This is the second step of determining the refrigerant system. Locations of refrigerant system are described by occupancy classification that consider the ability of people to respond to a potential exposure of refrigerant. Important note, where occupied or appliances are outside and within 20 feet of any building opening, the equipment is governed by the occupancy classification of the building. Let's look at the following occupancies to understand how they are defined. Institutional occupancy, occupants cannot readily leave without the assistance of others. Example, hospitals, nursing homes, asylums, and spaces containing locked cells. Public assembly occupants can't quickly vacate the space because too many people are congregating. Example, auditorium, ballrooms, classrooms, passenger depots, passenger depots, restaurants, and theaters. Residential occupants have complete independent living facilities include permanent provision for living, sleeping, eating, cooking, and sanitation. Example, dormitories, hotels, multi-unit apartments, and private residences. Commercial occupants transact business, receive personal service, or purchase food and other goods. Examples, office and professional building, markets but not large mercantile occupancies, and work or storage area but not industrial occupancies. Large merchandise occupancies, this is defined as more than 100 persons congregating to purchase personal merchandise. Industrial occupancies, this occupancy is not open to the public and has controlled access by authorized persons. Only it can be used to manufacture, process, or store goods such as chemicals, food, ice, meat, or petroleum as example. Mixed occupancies, this is two or more occupancies located with the same building. If occupancies are isolated from each other, the requirements for each occupancy apply to its portion of the building, whereas the occupancies are not isolated. The occupancy having the most strength requirements govern. System classification, International Mechanical Code 2021, Section 1103.3. Step number 3 determines the system classification. This is the third step of determining the refrigerant system. The classification is the probability that a refrigerant leak could enter occupied areas. Here is the ASHER standard 15 1994 refrigerant system probability. Illustration is low and high probability. This lower probability, this indirect vented closed as we see here, and here indirect closed, and here double indirect open spray. This open here, this going higher, indirect open spray, direct. Okay. Double indirect open spray system, indirect closed system, and indirect vented closed system pose low probability of leakage. Note that the pipes and fittings must be isolated should the refrigerant quantities exceed the value listed table 1103.1. Understanding practice. Direct system and indirect open spray system pose high probability of leakage unless the indirect open spray system has secondary cooling at a higher pressure than the refrigerant. System appliances requirement International Mechanical Code 2021 Section 1104. Step 4 determines the system enclosure requirements. The last two steps are intermingled in International Mechanical Code Section 1104. The maximum allowable quantity of refrigerant will be based on step 1 through 3, but we will talk more about that when we get to volume calculation. Study tip: the maximum quantity of refrigerant in table 1103.1 determines the enclosure requirements, which basically if a designated machinery room is required or not. Follow the next couple of sections to see how it all come together. Machinery room, International Mechanical Code 2021 Section 1104.2. This illustration 14R machinery room contain refrigerant equipment. Chiller in the image. This is the chiller in the image. They are regulated by the code because they will house high levels of refrigerant and therefore need health and safety regulations. Understanding the fields: if the quantity of refrigerant in an independent circuit of system exceeds the amount shown in table 1103.1, all components containing refrigerant must be located either outdoor or in machinery room. Machinery room are to be constructed and maintained described section 1105 and 1106. Refrigerant levels.
Refrigerant levels.
Refrigerant
Machinery
levels.
rooms aren't
See
required
this
for
one.
listed equipment and appliances
Okay.
containing less than 6.6 pounds of refrigerant, regardless of the refrigerant's safety classification. The piping used, and that is in conformance with Section 1107, is also allowed in other locations to connect components installed in a machinery room with those installed outdoors.
Institutional coupons, the amount shown in Table 1103.1, are reduced by half for all areas of institutional occupancies, except kitchens, laboratories, and mortuaries. This means that in hospitals, you are going to have to move your refrigerant equipment to a machinery room at lower quantity of refrigerant, 50% than the other occupancies. Fast facts: the total of all group A2, B2, A3, and B3 refrigerant can't exceed 550 pounds in the occupied areas or machinery room for institutional occupancies, example hospitals. Industrial occupancies have a unique code requirements for these occupancies and refrigerated rooms. A machinery room is not required so long as the following conditions are met. Industrial
Industrial occupancy
occupancy
exception to
exception to
having a
having
machinery room.
machinery room.
Let's read through these conditions together, and you can follow along with us. Okay, so number one, the space containing the machinery is separated from other occupancies by tight construction. Number two, access is restricted to authorized personnel. Number three, refrigerant detectors are installed as required for machinery rooms in accordance with Section 1105.3. Detectors aren't required in unoccupied areas with just continuous piping, and approved alternatives to detectors can be used for certain ammonia refrigeration. Number four, surfaces having temperatures exceeding 800 degrees Fahrenheit and open flames cannot be present or any group A2, B2, A3, or B3 refrigerant is used. You can see section 1104.3.4. Number 5. All electrical equipment and appliances should conform to Class 1 Division 2 hazardous location classification requirements of NFPA 70, where the quantity of any group A2, B2, A3, or B3 refrigerant other than ammonia in a single independent circuit would exceed 25% of the lower flammability limit upon release to the space. And finally, number 6, all refrigerant containing parts in systems with a total connected compressor power exceeding 100 horsepower are located either outdoors or in a machinery room. Note that evaporators used for refrigeration or dehumidification, condensers used for heating, control and pressure relief valves for either, low probability pumps, and connecting piping all are exempt from this requirement.
Refrigerant restrictions. International Mechanic Code 2021 Section 1104.3. Let's go over the number of refrigerant restrictions required by the code outlined in the section. Study tip. Remember, P refrigerant are bad for you, toxic, and A refrigerant are A, okay, non-toxic. The number is a flame rating. 3 is going to burn, but 1 will not. Notice that are no additional restrictions for A refrigerants. P1 to P3 group B refrigerant, P1, P2, P3 are not allowed in high probability system for air conditioning for human comfort, except in industrial occupancies. A2 and P2 is non-industrial occupancies. Group A2 and B2 refrigerants are not allowed in high probability system where the quantity of refrigerant in any independent refrigerant circuit exceed the amount shown in the table 1103.3.2. A3 and B3 group A3 and B3 refrigerant are not used except when approved. A2 and B3 A3 P3 for all occupancies. The total of all group A2, B2, and A3 and B3 refrigerant can't exceed 1,900 pounds.
Protection against decomposition. To protect a refrigerant from decomposing, any room with a device with a flame or surface temperature above 800 degrees Fahrenheit and containing more than 6.6 pounds of refrigerant in a single independent circuit requires one of the following. Let's look at them together. 1. A hood and exhaust system. 2. Combustion air brought from outdoors in a way that prevents leaked refrigerant from being burned. And 3. A refrigerant detector used to stop the combustion.
Volume calculations. This is International Mechanic Code 2021 Section 1104.4. Step number 5 determines the maximum allowable quantity of refrigerant. This is the last step for determining our refrigerant systems. Follow along with these scenarios as we close out this example, where the refrigerant containing parts of system are located in spaces that don't communicate through permanent opening or HVAC duct. The following volume of the smallest enclosed occupancies space is used to determine the permissible quantity of refrigerant in the system. Where an evaporator or condenser is in air system, the volume of the smallest enclosed occupied spaces served by the duct system is used to determine the maximum allowable quantity of refrigerant in the system. If the airflow to any enclosed space cannot be reduced below 1/4 of its maximum, the entire space served by the air duct system can be used to determine the maximum allowable quantity of refrigerant in the system. Illustration 14 is suspending sealed suspending ceiling, whereas the space above suspending ceiling is continuous and a part of supply or return air plenum system. This space can be included in calculating the volume of enclosed space, so it must be included. Think about it. After the volume of the space is calculated, cubic feet, multiply it by the value in column 5 of table 1103.1 IPS per CUFT to find the amount of refrigerant allowed in one circuit. Machinery room general requirements. International Mechanical Code 2021 section 1105. If it was determined that a machinery room is required in step 4, determine the enclosure requirements. Then International Mechanical Code 1105 and 1106 get into the detail of what that mean and what need to be included in machinery room. Illustration 14T refrigerant detector. Refrigerant detector in machinery room shall be provided as required by section 605.8 and section 605.17 of the IFC. This code is outside of our
Open
reference
flames.
for
Fuel
study.
burning appliances and equipment
Open
having open
flames.
flames that use combustion air from the machinery room are not allowed unless the refrigerant is carbon dioxide or water, or a refrigerant detector is used to automatically shut off combustion.
Ventilation. Machinery room require ventilation. Natural ventilation can be used where a refrigerating system is outdoor more than 20 feet from any building openings and is enclosed in an open structure. The ventilation opening cannot be less than F equal square root of G, whereas F equal the free openings area in square feet, G the pounds of refrigerant in the largest system in the machinery room. Natural ventilation is not commonly used. However, here are the requirements for machinery ventilated machinery room. Illustration 14U in indoor mechanical exhaust intake opening. Indoor mechanical exhaust intake opening should be located where refrigerant leakage in likely concentrate also make up air
Supply
to
and
replace
exhaust
exhausted
duct
air
servicing.
must provide.
Supply and exhaust ducts to the machinery room cannot serve any other area, and the duct opening must be covered with a corrosion-resistant screen of at least 1/4 inch mesh.
Understanding design, there are two conditions that must be able to be satisfied: a continuous exhaust under normal condition and an increased exhaust rate under emergency condition. These are sometimes uh, satisfied by two-speed fan or by two separate fan system. Here are the exhaust air quantities required for each of the condition. Under normal air quantity condition during occupied conditions, the mechanical ventilation system is to exhaust the large of the following. Number one, 0.5 CFM per square foot of machinery room area or 20 CFM per person. Number two, a volume required to limit the room temperature rise to 18 degree Fahrenheit, taking into account the ambient heating effect of all machinery in the room. Note that most machinery rooms have a separate means of cooling the machinery room from the exhaust, and these options won't be used under emergency air quantity condition. Upon actuation of refrigerant detector, the mechanical ventilation system will exhaust Q equal 100 square root of G, whereas Q is the airflow in cubic feet per minute, G is pounds of refrigerant in the large system in the machinery room ventilating ammonia. The ammonia is the minimum required Emergency ventilation rate for ammonia is 30 air changes per hour. Think about it, multiple fans or multiple speeds fans are allowed to produce the emergency ventilation rate and to obtain a reduced airflow for normal ventilation. Here, illustration 14V, refrigerant relief. This refrigerant relief. Pressure relief devices, fusible plug and purge system located within the machinery room must terminate outside of the structure at least 15 feet above the adjoining grade level and at least 20 feet from any window, ventilation opening or exit. Machinery room special requirements. International Mechanic Code 2021 Section 1106. The code gives us special requirements for machinery room that have group A2, B2, A3, and B3 refrigerants. Just know where you have to go to look up these special requirements if it's come up. Example, a clearly identified emergency switch is required to provide of only control of refrigerant compressors, refrigerant heat your refrigerant pumps and normally closed automatic refrigerant valves located in the machinery room. In addition, a clearly identified switch provided on only control of the machinery room ventilation fans is required. Refrigerant piping, International Mechanic Code 2021 Section 1107. Refrigerant piping can pass through a myriad of area and materials. Sometimes piping need to run through a concrete floor. Refrigerant piping installed in concrete floor must be encased in piping ducts. Illustration 14W enclosure requirement. Pipe enclosures are required for soft annual copper tubing containing other than group
The
A
damage of condensation.
or B
If
refrigerant.
condensation forms on piping, the condensation will eventually cause a safety hazard or damage. Piping must be protected to prevent such damage.
This table is illustration 14x piping for various refrigerants. This is piping for carbon steel pipe, for example, carbon steel copper tube type ACR. This A or B refrigerant with every refrigerant. This chart shows the common piping allowed depending on refrigerant used. Let's see the quiz for the chapter. Number 1, refrigeration system containing 60 pounds of refrigerant serves a 2,000 square foot medical clinic with a 10-foot ceiling. Which of the following refrigerant would required or refrigerant containing components be in the machinery room or outdoor? These are 12. What type of refrigerant system is chilled water circulated from chiller containing refrigerant to air handler coil in closed circuit in direct closed system? Plume discharge for cooling tower are required to be at least 5 feet above or 20 feet away from any ventilation inlet to building. To what does the first letter of refrigerant classification A or B refer to? Health hazard of refrigerant. Health hazards means toxicity. Ammonia is a common refrigerant in a refrigerated warehouse. There is little mention of ammonia in the refrigerant chapter, and it is not included in the table of refrigerant. What is the reason to this? Ammonia is governed by another set. Reference is 2AR2 through 5. Let's back to module. Now here we finished the course, okay, for this international commercial inspector. Okay, so this is the last one, and the next video it will be about testing. This very important video, it will be about testing strategies for commercial mechanical exam, how we pass the exam, and after this we will finish with two exams.